MQTT is one of the main type of protocols that you can use in real-time IoT applications. So in this video, we'll be discussing on how you can connect an MQTT cloud broker with ESP32 and a custom backend through TLS verification. So let's begin. So in this video, we will be covering these few topics, which is the running of the MQTT broker with making the accounts and all. And we will be covering on how you can obtain the intermediate and root CA certificates and how to configure the ESP32 and the Node.js application with the certificates and how the complete process can work. So we are providing the codes for ESP32, Node.js, and how you can do testing. So we will be providing them. And the hardware you need are the ESP32 development board and USB to micro USB cable. So the softwares, first you need to have the Arduino IDE installed, and in there you need to install the ESP32 board. It can be installed through the board manager, and the Node.js and NPM should be installed on your computer. So it's necessary to run the Node.js script, which we are running as a backend. So for Postman, you need to have it installed, or you can use the web browser. It is an API testing tool, which we are having some RESTful APIs. So we are testing the APIs through Postman. And the accounts you need is one which is a cloud MQTT broker, which named HiveMQ Cloud. So we will be telling you how you can set up it. So first you need to understand what these certificates are. So the root CA certificate and the intermediate certificate. So talking about the root CA certificate, it is issued by the trusted certificate authority, and it can be used to sign the other certificates. So it is a trusted certificate by clients and the systems. So talking about the intermediate CA certificate, it is issued by the root CA, and it further enhances the security by adding layers. So the certificate chain, it's like this. We send the certificate and we do the handshake, TLS handshake, and after that only the connection is established and data is transferred. So that is how the chain goes. And first of all, you need to create the HiveMQ cloud account. You can use the free version of it. It is a serverless free plan. So you can make a new cluster and create the account. So let's see how it goes, and you can see when you create the new cluster, you can upload, you can add the username and the password, and finalize the account, and you need to note down the URL and the username and the password you set. So those are the things you need to make sure when creating the account, and you can use the Gmail to sign up. So that's how you can create the account. And when obtaining the certificates, as I said earlier, you have noted down the host name. So through the host name, we are able to get the certificates, and you can type this line on the terminal and get the certificate. And after that, you will be getting the 2 certificates that can be used. So you need to make the 2 certificates in this format, and this is the format that needs to be added on the ESP32 code. And let's see how you can implement the ESP32 code. So after making the setup Arduino IDE, so after that you can install the libraries PubSub client and Wi-Fi client secure, which you can install it through the library manager. And let's talk about what the code snippets are, and I will explain each of them. So the Wi-Fi and the MQTT credentials should be included in the code. It's as per your SSI and password of your router, and the MQTT server hostname should be added in the code, and the username and the password you have set. So those things should be added. And in the certificates, as I said earlier, it should be in this format. You can replace the paths, the intermediate certificate content, and the root CA certificate content here. And after that, you need to initialize the Wi-Fi and MQTT clients. And for synchronizing time, we can use this set of lines. So basically, this is required for TLS verification. So and the setup function, you need to have the connection between the connection with your network, and it configures the TLS, and then it starts it sets the server, and it starts the callback function. So here's the callback function we are using to receive the data after subscribing to the topic. So this is the function related to reconnection. So this basically reconnects until it tries to reconnect until it's connected. So that's the functionality of it. And in the main loop, you will be seeing this which tries to reconnect until it's connected, and it publishes the data through the MQTT topic, and after subscribing you will be able to publish the data. So here's the complete code. As I said earlier, you can replace this, and these are the topics that we are subscribing to. And the first two topics, the first topic, data for sending publishing the data, and this topic is for listening. So this part is for listening, and this is the complete code. You can just copy it and paste it on Arduino IDE and change the necessary paths and upload the code. And after that, here's the response you will be getting. So you will be seeing the published data printed on the serial monitor, and if there's any data received, you will be seeing the data arrived for that particular topic. So for creating the Node.js application in the computer, you can just create the directory through the first command. You can run it on the terminal, and you can navigate to the that particular folder, and then initialize npm. So after that, you can install these libraries through this command which are needed in the code. And after that, you can just copy this complete code and paste it on a text file, or you can use VS Code. So we have used VS Code to run this, and just you need to replace the host name, password, username. So after that, everything will be set, and you need to connect your computer to the same network that you used for ESP32. So that is an essential thing to consider, since we are running the backend in locally. So you need to have both of them in the same network. So after that, let's discuss what these code snippets are, and these are the modules that we are using that we install through that command, this command. So the initialization of the Express app, and after that it connects to the MQTT broker through this code, and the event handling part which we subscribe, and we receive data to a particular topic through this code snippet, and we set the server, and those are the things, the key parts in the code. So after that, you need to run the code through this command. You can just run it on the terminal. So you will be getting the response as this. So we will be seeing the data received through the ESP32 and coming through with the MQTT broker. So these are the data that you are receiving. So after that, in the code, we have added some RESTful APIs to send and receive data. So that can be tested through a API testing tool like Postman. So in here, there are some APIs for get the latest data received from the ESP32, and this API is a post request to send data from that API tool, testing tool to ESP32. So let's see how you can do that. You can open Postman in browser. You can install it on your computer. After that, let's see how you can make the get request. You can click get request there. There's a drop down. You can just select it, and you can type the endpoint here, and you need to replace IP with your internet connections IP. So you can find it from Wi-Fi settings. So through that, you'll be getting the IP you have connected with your computer. So you need to replace it and then run this get request, and you will be seeing the data, the latest data received to the backend. So for the post request, we can send data to the ESP32 through this, and you need to copy this and paste it and replace the IP. And we have sent a command start, but you can just replace with anything you want. So the data is structured as this with the post request. It should be a JSON file, and we'll be seeing success. So after that, you may see the data received on the ESP32. So complete transference of data from ESP32 to Node.js backend, and Node.js backend to ESP32 is discussed. So if you need to further increase and improve the latency, so you can use WebSockets instead of RESTful APIs. So that is an option for you to further increase the latency, so further improve the latency. So this is the article, the video that we are trying to give you the basic idea of how you can connect the MQTT server with the ESP32 and the backend. You can just use this and make your own application. So we have developed a IoT design tool which you can use to create your own IoT device or the system, and we guide you through the process through articles, through dividing the large process into small parts. So you can try this. Here's the link, and if you have any questions regarding the MQTT protocol and how you can implement it in yours, you can contact us at info@protonis.co. So you can contact us at any time. So we are specialized in IoT and embedded systems, and good luck on your projects. Thank you.